So with all these separation techniques, I'm going to focus on what the syllabus point is about purity. And so I'll just talk about how to increase purity for all of them. This one's the separating funnel is quite interesting because there's many different ways you can separate it out depending on whether the substance you want is in the top layer or the bottom layer. You can also just have it in one layer and then put some other layer in there and then shake it up and down and mix it to separate it into a layer that's more soluble for it. And so you can remove this layer if that's what you want to do, and either get rid of it, or maybe that's the layer you want to keep. And so technically you're removing the top layer. And so there's lots of different ways you can go about using a separating funnel for getting the substance you want, depending on where it is. And so how do you purify that? Well, what you would do is you just repeat it with the washing. So say if what you wanted was soluble in one of these layers here, you would shake it up and down and wash it, and then either keep this layer and do it again, or just remove this layer if it's in this top layer here, and then re-add that layer that you just got rid of, and then shake it up and down and wash it again. And you just keep on doing that several times until it gets more and more pure. And so again, it depends on which layer it is that it's in. And so going on to the next one. So filtration is an interesting one. This one here, if you want to purify it, say you want the residue, you would just put some pure water down there and just keep washing it out to try and get rid of as much of this filtrate as possible. If it's the filtrate that you actually want, that would be interesting, and we'll talk about that at the end, what techniques you can use for that. Now, a little bit more advanced than that is using this specially designed funnel that forces, this is a porous sort of plate here with a filter paper there to stop the mixture all falling through, and to use a vacuum to force out the liquid there to make it work just a little bit better and speed it up. Now, this is one of the main ways that they purify things. It's to get it into a crystal. So the key with a crystal is the molecules line up perfectly, and so they form this little this crystalline sort of structure. And in the process, they exclude all these other impurities or other molecules that don't match up and form into this perfectly lined crystal. And so they're sort of excluded as they form that crystal. And so what do you do once all the water's gone, or even if there is some impurities here? You can collect the crystals and redissolve them in pure water and just do the whole process again, and even wash the crystals a little bit. You might lose some of it if that dissolves, so wash it with very cold water just very quickly, and then redissolve it in slightly warmer water and recrystallize again. And again, this process of crystallization excludes impurities. So you're recrystallizing several times. Now, this one's mainly to do with oxidation of alcohols at the very end of the course. And so what's happening is you're separating it out based on different boiling points. And so the one that's more volatile will come up, and then this is cold here, and it'll condense, and you can collect it here. And the other compound or compounds that have a higher melting boiling point, won't boil off first, and that'll be separated that way. Just an interesting point is countercurrent flow. And so you put the water in here, not at the end, because at the end here is when the substance is the coldest. And so you also want the coldest water to interact with the coldest substance. Here is the most, it's the warmest. And so as the cold water heats up along here, it's not so critical. And so you want the coldest amount of water possible when you're at the very, very end. And that's called countercurrent flow. And that's quite important for physics, for environmental issues about how to get the most heat out. It's also the reason why fish can pull out so much oxygen out of a very, very low concentration in the water, because of countercurrent flow. So the blood vessels are in the opposite direction to the water flow. And so when the water oxygen content is its least is when the oxygen cells have the least amount of oxygen on them to absorb that last little bit. So counter current flow is the reason why it's in the opposite direction. And it's quite an important concept. Now, purity, I've seen this one 6 in a row in a university lab. So they just collected that, and I think it went straight into another one like this, and then out like that, and then that went straight into another one. And so it was just a continuous process all along, and this was electrical, and it was just left there. I don't know how long, but definitely overnight. And so it was just continually doing this over and over and over and over to get it to purify it out of a mixture of organic compounds. Okay? So obviously you don't have the ability to do that or reason to do that in a classroom. And so here, this one here is very similar, except what you want to do is it's volatile and it comes off as you heat it, but you want it to still react. And so what you do is the same deal. So when it's at its coldest, you get the coldest water, and it's still counter current flow. It'll cool down and condense back in and keep reacting. And so that needs to be free. Otherwise, there'll be a buildup of pressure and an explosion, which happened when I did first year chem. I wondered why there was electricity and light and fire and glass pouring all over a particular student. We found out that they'd put a lid on this, and then it popped off and shot off and hit the those old lights, fluorescent incandescent lights that used to have glass and went everywhere and sparks went everywhere. It was quite dramatic. Okay, so don't put a lid on anything that builds up in pressure. All right. Probably won't be such a disaster with LEDs these days. Okay, chromatography. This is a huge area. You can have gas chromatography, high pressure, liquid chromatography. You can change all sorts of weird things with the solvents. You can use electricity. It just goes on and on and on. We're just trying to keep this one fairly simple. So we're only using paper or thin layer chromatography. Thin layer chromatography has these chemicals here. Paper has cellulose. All of them have polar groups on them. And you're usually using different types of polar substances. And we're separating things by the degree of polarity. And so the more polar a substance, the better it will stick with the polar solvent, if that's what you're using, and it'll travel up further. And this one does go, we do calculations later on, so I might leave it at that before we do more detail in another topic. And so lastly, this is to do one of the syllabus points of how do you separate substances from acid reactions because of the differences in solubility. The first one is everything's soluble. So these are the various reactions that could occur. And they are acid. What have we got? Acid and base, acid plus carbon, acid plus metal. Hopefully you've learnt that in junior science. We will cover it again. And then the product, the salt you want, is always aqueous. And so you have to crystallize it off. And the purity, I've already talked about how to just redo things to make it pure. So you're either going to do a titration to work out the exact concentrations first, and then you can add the correct amounts to know that you've got it perfectly neutralized, not too much acid or base left over. Or as you're doing the titration, you can get a stirring rod and just pull a little bit of it off and test it on universal indicator paper until it's neutralized. And then you know you're done and you're ready to do the crystallization process. With this second one here, you are getting two soluble salts together, and it's a double displacement reaction. And the one that you want is an insoluble product. And so basically you just wash out all the remaining product, and maybe there's excess of one of the reactants. Just wash it all through, and you just keep what you want, which is here, and you can just wash that with more pure water and dry it and keep what's left over in the filter paper. And lastly, if you have insoluble reactants, so you would add excess metal again, because you don't want any acid left over, because you don't want that concentrating or causing problems. And so what you'll then have is, what you want to keep is the remaining liquid here, and you will have salt left over, and you assume that all the acids must therefore have been completely reacted. So normally you would actually do that reaction separately. and warm it up so you have time to mix, and so you're completely confident because there's leftover metal that there is no acid left. And so you remove that excess metal, and all you've got is liquid with the salt that you want. These gases have come off if they're the reactions you're using, acid plus metal, acid plus carbonate, acid plus base. And so all you need to do is remove the water now. And as we talked about before, for purity, you just recrystallize it, wash it, etc.